Let's go ahead and finish up this unit with section 11.5, more on triangle congruence theorems. So this one says, I can understand, so we know how to say this now, angle, side, angle, and the next one is angle, angle, side congruence. So we're going to learn two more theorems that we can use to show that triangles are congruent. So the warm-up here, let's just talk about what we did last time. So it says triangle PQS is congruent to some other triangle down here, and we need to know what the reason is. So we'll cite one of those theorems from last time. Now again, this is going to come up on both of these. This is a common thing. There may be information that is not marked on a diagram, but is included information just because of what you know about these, and that is this right here. This side right here, PQ, is used in both of those triangles. So if we were to break this apart into two triangles, PQ would be on both those triangles, so it clearly would be congruent to itself. So I'm going to go ahead and put two marks on there. So if they said PQS, so PQS, we've got to write the other one down in the right order. So PQS would correspond with PQT. So we're going to write PQT over here. And again, just to note how these need to be in corresponding order. See how this S is off all by itself, and it's right next to the one with one hatch mark on it? T is over here all by itself, and it's right next to the one with one hatch mark on it. So they are in corresponding position there. And then the reason, of course, would be because we had a side here and a side here that were congruent, an angle here and an angle here that were congruent, and then that side right there that was included with both of those. So this is going to be side, included angle, and side, side, included angle, and side. So this is going to be side, angle, side, one that we learned about last time. And then for B, it says, what other information is needed for side, side, side congruence? Well, right now it only looks like we have a side here and a side here, but that's not actually true. Remember, we know that that side, FG, would be congruent to itself when we used it on both the triangles. So really all that we need here is we need to know that that side right there is congruent to that side right there. So we're going to say that we need EG to be congruent to QG, and then we'd be all set to go. Now, there are two other congruence theorems that we need to learn in this class. One of them is angle, side, angle congruence. So the formal statement of this is if two angles and the included side, so that's why it's, again, angle, side, angle, of one triangle are congruent to two, again, angles, and the included side of another triangle, then those triangles are congruent. And like we did last time, we're going to take this and we're going to do a couple of the transformations that we learned about so that we could show this. So again, I've got these two guys right here, and notice that they look like they're congruent triangles, but they're oriented differently. So you'll notice that we have, like we have an angle here corresponding to another congruent angle over there, a side here, an included side corresponding to another congruent included side right here, and then of course a congruent angle A with congruent angle D. So we have angle, side, angle here, and angle, side, angle on this one. Now, we're going to use some transformations. So how do we get the two of these together? Well, the way we get the two of these together is we just do a translation. We just slide them together. So translation. Okay, and then to go from this one to this one, notice that B lands on right on top of E. So what we've done here is we've just done what would that be? That is a reflection. So we've done a reflection. Okay, so a reflection. And remember, the only transformation that doesn't preserve congruency isn't a rigid transformation, is going to be a dilation. So these definitely are congruent, and you can kind of see that they lay right on top of each other. Now, because of the properties of the angles in a triangle, we can reason our way to another one. So we've got enough information. We don't need a bunch of fancy stuff on this one. This is angle, angle, side congruence. And it says if two angles in a non-included, so non-included side, that's going to be the one that's not in between the two angles, of one triangle are congruent, of course. So congruent. Okay, congruent to two angles in a non-included side on another triangle, then the triangles are congruent. So I want you to take a look at this diagram right here, and let's see if we can figure out what's going on. It says use the diagram to explain why angle, angle, side theorem. Why is that theorem true? Because if you take a look at this, we've got an angle here, another congruent angle there, angle here, another congruent angle here. No information about that one right there, and no information about that one right here. But what we've got is congruence on this non-included side right there. So the hint on this one is if you know two angles, so if we know these two angles on this triangle, and we know these two angles on this triangle, wouldn't we automatically know the third one? Okay, then we automatically know the third angle. Okay, so if you have angle, angle, side, so if you have angle, angle, side like this, angle, angle, side like this, well, what we can automatically say is, look, if these two are congruent to those two, then we can come through here and we can say, look, that third one's got to be congruent. So if you have angle, angle, side, you will automatically have angle, side, angle. Now I'm going to let you take a look at that for just a second. By knowing the two of these, and we don't have the side in between those that we need, we automatically know the third one, and now we can just shift our attention over here. Now we have angle, side, angle, angle, side, angle. So by having angle, angle, side, it's almost like we've got this. It's almost like we've got angle, side, angle, angle, side, angle. Okay, so angle, angle, side, angle. If we know these two angles, we automatically know that one. Due to the, let's see, triangle blank theorem. How do we know that third side? How did we automatically know the third one? Well, remember, we wrote this down the other day. It's because of the triangle sum theorem. It's because of that whole idea that they always add up to 180. So whatever these add up to, these would have to add up to the same one, and that means that last angle would have to be congruent. Okay, so that's how those work. We've covered 4 theorems. Let's go ahead and practice some of the ones that we've learned here. So you can probably tell I've clearly got a typo. This should be angle, side, angle, and this should be angle, angle, side. The ones that we've learned about today. So let's go ahead and take a look at this. So hopefully they apply. So on this one, we've got a triangle DEC. So DEC, we want it to be congruent to this triangle over here, but how do we know that? Again, we may need some background information for this. So let's take a look here. We do know that these two lines intersect, and that makes congruent angles, congruent vertical angles, remember. So now what we have here is we have an angle and a side and an angle that corresponds to a congruent angle over here, congruent side over here, and congruent angle over here. Because remember, right angles are always congruent to themselves. So for DEC, we went from right angle to no arcs to one arc. So over here, we need to go from right angle to no arcs to one arc. So this would be A, B, C. And again, notice what we've got matching up here. C clearly on both sides of that, those would be congruent. A and D, those should be in the same spots because those are the right angles. And notice that the B and the E, the ones that are in the middle, those don't have an arc at all, so those would have to correspond to each other. Okay, so what we used here is we used, let's see, angle, side, angle. So let's go ahead and put that down. And then for triangle BEC, we want it to be congruent to another one. So let's see here. And it is possible that there's not enough information to tell. But let's take a look. Let's see. We've got some vertical angles right here. So I'm going to go ahead and mark those. And then remember what these lines mean. Those lines mean that we have parallel sides. This line's parallel to that one. And that means that alternate interior angles are congruent. So I'm going to go ahead and mark this one right here. So I'm going to mark this angle right here. I'm going to do 2 marks there, and I'm going to do 2 marks there. So what we've got so far is we've got angle, side, angle, angle, side, angle. So we could say that those are congruent. And again, if we did BEC, so we're going to do 1 arc to 2 arcs to none. So 1 arc to 2 to none. So we're going to do BAD on this one. So that would be triangle BAD. And the reason that we did that was angle, angle, side. Now, some of you may be looking at this and thinking a little bit past what I was doing and say, well, gosh, if this is a transversal also, and those are congruent, parallel sides, couldn't we do this? Let's do 1, 2, 3 here, and let's do 1, 2, 3 here. And then couldn't we do angle, side, angle on this one? So angle, side, angle on this one. So I'm going to put or angle, side, angle. Okay, so either one of those. Angle, side, angle, and angle, angle, side are really closely related. So let's take a look at this last one. It says we want to show that triangle GFH, so GFH, so this upper triangle right here is congruent to this lower triangle right here. So let's see if we can do that. We know that those angles are the same, and we know that because this side would be included on both of them, I'm going to go ahead and put a little mark right there. Do we know anything else? So we've got a side. Gosh, if we could get one of these angles here or something like that, then I think we'd be okay. But on this one, I don't think we've got that information. If we knew that we had some parallel lines or something like that, we'd be in great shape, but we're missing that. We don't have that like we did on this last one. So we're just going to write not enough info. We can't make a conclusion about congruent triangles. Okay, let's look at the other side. Okay, it says, state what additional information is needed to make the congruent statement based on the given theorem. So again, the theorems that we learned today. So we need angle, side, angle. Well, this one's pretty clear. If we're going to show that this one is congruent to that one using angle, side, and angle, it's got to be this one right here. So we're going to need that side AB is congruent to side DE. So we'll mark that one down. If we're going to do angle, angle, side here, so remember, angle, angle, side means that the side can't be included between the two angles. So we can't do this one right here. That's not going to be good because that would make that side included. So we've got to do the other one over here. So I'm going to put 2 marks right there. And again, it's got to be the one that's not included, so that's going to be this one over here. So we need to know that angle A is congruent to angle D. All right, and then this last one by angle, side, angle. And remember, we've got some unmarked included information right here, and that is that we've got vertical angles right there, so those two are congruent. And we want to do angle, side, angle. So if we do angle, side, that automatically puts this one right here, so that's going to be angle B. Angle, side, that's going to be R, so we're going to do angle B needs to be congruent to angle R in order to show that by angle, side, angle congruence. Now, those are the only 4 theorems that we're going to do for now, just side, 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 angle, side, angle, and angle, angle, side. There are some others, but they mostly include special cases like right triangles that have hypotenuses and legs and stuff like that. The thing we really need to keep in mind is the reason that these congruent theorems are true. And the reason it's true is because we can use transformations to make it so one triangle lines up with all the corresponding congruent parts. They're right on top of each other. So when we slide them over, flip them, reflect them, and stuff like that, so that we can make it look like this one is right on top of that one. So on this one, we might need to flip this around and spin it or rotate it or something like that. On this one's easy. We just slide it over here with a translation and we're all set to go. But we can use transformations in order to make them line up. The only transformation we can't use, of course, it's a dilation. Okay, can't use a dilation because that's going to change the size of the sides and we need to be them exactly the same. Now, we've covered all of these 4 right here, and a natural question would be, there's a couple that are missing. So we've covered all the combinations except for AAA, so that's angle, angle, angle. And remember, we use angle, angle, angle to show similarity, but what about this one right here? Now, most people say this is side, side, angle, but you may be thinking like most people, especially young people, if we just flip that around, it's a word we probably shouldn't be saying all the time. Okay, so here's the necessary question. What about side, side, angle, or angle, side, side, if you wanted to think of it that way? Well, I always tell students, if you see angle, side, side, you ought to be really careful. Okay, things are not always as they appear. And what I'd like to do is I'd like you to show why we need to be careful with this. Now, one of them is a little page that you can read on that website that we looked at before by John Page, that Math Open reference. And then the other one is a video, and there's a little bit of humor, and then we're going to come back here and we're going to take a look at a diagram. So here's the first thing I want to look at. I want to look at this right here. So this is angle, side, angle congruence. So you'll notice that this is that page we were looking at before. I can take this, and again, the blue parts up here, those are the parts that are set. And by moving this around, you can see that this angle stays the same as that angle, this side stays the same as that side, and this angle over here stays the same as that angle. But these triangles, they still stay exactly the same. So this is angle, side, angle. And then angle, angle, side looks like this. Again, you could drag any one of these around any way you wanted. That blue side, that blue side, that blue angle, and that one right there. Again, move these any way you want. As long as that angle, angle, side match up, then we're going to get 2 congruent angles. Now, here's one reason why side, angle, side doesn't work. So we've got angle, side, side doesn't work. So we've got an angle, a side here, and then a side right here. So this angle is congruent to that angle right there. this side is congruent to that side right there, and this side is congruent to that side right there. So most people would say, well, what's the problem then? This is totally fine. The problem is because we don't know this angle up here, this angle B right here, and this angle Q right there. I want to show you the other thing that could happen. Watch what happens with this side QR. Another triangle that we could make would be made by swinging this one. Instead of swinging it out, we could swing it in. So it turns this acute angle right here into an obtuse angle. Now, if you look at these, it's really tough to argue that these are not the same angle, and side on each one of these. So let me again show you the other one. That's where we swing the side out to make a little bigger triangle, and this is where we keep it in to make a little bit smaller triangle. So that's one reason for it. It might be good if you went through and read the entire page here because there's some good information there. And I do want to show you one more thing. So I'm going to go ahead and flip to this one right here. This is a YouTube video. This is Mashup Math. Looks like 21,000 views. He's got a lot of subscribers. Let's go ahead and take a look at this right here.
So now that we've covered the 5 triangle congruence theorems, you may be asking, what about angle side side? Please don't be uptight. Okay, so now let's go ahead and explore why angle side side would not work as a triangle congruence theorem. So if we have a set of corresponding angles that are congruent and a set of corresponding sides that are congruent. Okay, so we have 2 sets. We have an angle followed by 2 consecutive congruent sides. The issue is with that second congruent side, since we don't know the angle in between the 2 congruent sides, we don't exactly know its position. So I could take that side and swing it over to a new location and still show that angle side side is still the case here, no matter how I choose to draw that second triangle. And I have the option of drawing it either way, since that's an isosceles triangle, so both of those sides are definitely congruent to each other. Now if I draw it this way as an acute triangle, I see that I have angle side side, however, the base of each triangle clearly are not the same, and these triangles clearly are not congruent. So due to this ambiguity, angle side side or side side angle is not enough to prove that 2 triangles are congruent.
Okay, so let's come back over here and take a look at this. I've got a diagram right here that kind of illustrates what's going on there. So what we have is we've got this angle that's set right here, and then we've got side B, and then the side that's next up, that next consecutive congruent side is side A. So we can either swing side A out here and we get this big triangle out here, or if we choose to, we could swing in here, and you'll notice what this gives us. We've got the same angle and the same side, and then we've got this other side A right here. So it's really the difference between these 2 angles. One of them looks like this, okay, and the other one looks like this. Okay, so congruent angle, congruent angle, congruent side, and that one right there is still congruent, but you've got 2 choices. So we might have 2 triangles, at least for now. Okay, so we would need more information. More information. We'd need more information if we had angle side side or side side angle. Okay, let's come down here, and the last thing I want to take a look at is congruence and similarity or not sure. What can you say if you are given each one of these? So you've got to make sure that we've got this straight. So if we have angle side angle, was that one of the 4 that we talked about? It was, so we can show congruence right there. What if it was side angle side? We can also show congruence. That was one of the 4 that we studied in this unit. Angle, 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 this is what you talked about in 8th grade. For that, you can just show similarity. What about side, side, side? This is that thing that makes a triangle such a stable shape. If you've got side, 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 they are stuck, they are set, so they're going to be congruent triangles. And then we've got side, side, angle. This is the one that if you read it backwards, you better be careful. On that one, we don't know. We need more information. And then, of course, angle, angle, side. Again, the cool thing about this is because of the triangle sum theorem, if you've got 2 angles and a side, it doesn't matter which angles and side you've got, you'd automatically be able to show congruence. Okay, so go ahead and do the self-assessment there, and then good luck on the assignment. Next thing up would be the practice test. Good luck on everything.